Hi everybody. I, Jyotsna Lakshminarayanan, along with my teammates Mallika Tiwari and Prashant Doshi, take immense pleasure in presenting you through our project, Time Prediction and Analysis of Crime. We would like to thank Dr. Brian Hammer for his immense support and guidance throughout this project. We now have the agenda of the project. We will have a brief introduction of the project, followed by the methodology handled for the project. We will then move on to a discussion about the scope of the project, the data preparation phase, and the exploratory analysis. We will then talk about model building, assessment of the models built, and end the presentation with the lessons learned. According to a recent study, San Francisco has the highest crime rate of 62 per 1,000 residents and emerges as a city that has one of the highest crime rates in the United States of America. Our team has analyzed the historical crime data of San Francisco and came up with an innovative idea of predicting the time of occurrence of a particular crime that is prone to occur at a particular location in the city. We believe that predicting the time of occurrence in the city would be of great use to the Department of Police San Francisco and the people who reside in the city so that they take necessary precautions to overcome the crime incidents. We now discuss about the methodology in which the project is done, the CRISP-DM methodology. The project starts with a basic understanding of the requirement. We then have the raw data to play with and come to a deep understanding of the raw data. After understanding the requirement and the data, we have the data preparation phase. The data preparation takes almost 80% of the time where we do data consolidation, cleaning, transformation, and reduction. We then have the data modeling, followed by the model assessment and the deployment. Scope of the project. The main objective is to predict the time at which a particular type of crime is prone to occur at a specified location in the city of San Francisco. Apart from this, we also intend to analyze the crime incidents that had occurred over the last 4 years. We also aim at providing the statistical report of the time at which most crimes occur in order to provide an overview of the time of high risk. We aim at providing the location at which the crime rates are high at San Francisco, also the type of crime that occurred the most in the city. We now have the most time-consuming part in the project, the data preparation. This phase has 5 different levels and starts with data access, then data consolidation, followed by data cleaning, the data transformation, and then data reduction. Data access and consolidation. The data is obtained from the site SF Open Data maintained by the government of San Francisco. The data in this site is present from January 2003 to December 2015. In our project, we have limited the scope to 4 years starting from January 2011. The data in here is a single, well-organized spreadsheet eliminating the need for data consolidation. The data cleaning. In this part, we have checked the data for outliers, missing values, and erroneous data. From the table, we understand that the data doesn't have any missing values for any of the variables. Also, through the box and the whisker plot, we can see that there are no outliers in the data, making the data cleaning part simpler. Coming to data transformation, the data here is checked for normality. The values of skewness and kurtosis are also obtained. It is seen that the values of skewness and kurtosis are close to 0, which is almost normal. In the histogram plot, we see that the trend follows the normal curve. The histogram of time goes hand in hand with the normal curve. Similarly, in the QQ plot also, we can see that the plot for time blends well along with the normal line. We now have the data transformation. In the data transformation, we have 2 new variables created. They are time zone and converted time. The most important part of the project is binning of time. In the variable time zone, the time variable is binned into 3 groups: 12 AM to 6 AM, 6 AM to 6 PM, 6 PM to 12 AM. So, the time predicted will fall under either of the bins. In case of converted time, it is a combination of date and time. The sample data for time zone and converted time is shown. Data reduction. In the data reduction, we have a few levels in the category type of crime that occupy negligible percentage in the data and are not important. Such levels are removed from the data. Apart from this, under the category Others, there is a sublevel of crime called driver's license suspense or revoked. This sublevel occupies large percent of the observations and is of most importance. Hence, this sublevel is taken as a separate category. The data set at the end of the data preparation phase is shown. This data set is free of outliers, missing values, and is normal. We now have the data dictionary. We have 14 variables, out of which 3 are continuous variables, 8 are categorical, 1 date variable, 1 time variable, and 1 daytime variable. I now hand it over to Malika to discuss about the exploratory analysis.
Thank you, Jyotsna. That was indeed a very good introduction. I, Malika Tiwari, will be presenting you exploratory analysis phase of our project. We use Tableau as a tool for data visualization where we got different statistics of the data. We performed univariate and bivariate analysis on a variable and decided which modeling technique should be used. The first visualization in the form of word cloud shows that larceny or theft is reported to be the highest frequently type of crime that occurs in San Francisco. It has a count of around 32,000 out of the 93,000 crimes reported in San Francisco, followed by non-criminal, assault, and vandalism in decreasing order. Visualizing through the heat map, it is observed that the highest frequency of the crime has occurred between the time frame 6 p.m. to 9 p.m. The crime reported at this time frame is around 17,000. It is followed by the time frame 3 p.m. to 6 p.m. and 12 p.m. to 3 p.m. in descending order. It can be inferred that most of the crimes has occurred around the evening, that is 6 p.m. to 9 p.m., and the lowest in the early morning, that is around 3 a.m. to 6 a.m. This horizontal bar plot clearly tells that most of the crime has occurred in southern region, followed by Mission, Northern, and Central in decreasing order of the crime occurrence. The least number of incidents reported are in areas like Park and Richmond. We can see that resolution taken for assault, driving offences, and warrants are mostly arrest. But we can say that most of the crimes, no action was taken. This is an alarming issue as if no steps is taken for resolving the crime, we are inviting crime rate to be the higher. This heat map shows how crimes at police department districts like Southern, Mission, and Northern is happening the most at around 9 p.m. to 12 p.m. and 3 p.m. to 6 p.m. In order to assess the model built, the team partitioned the datasets into two, training and validation. The training dataset will be used to build the models and perform model analysis. The validation dataset will be used to assess the model that is built using the training dataset. The dataset is partitioned as 60% and 40% of training and validation dataset respectively. The team decided to divide the datasets into two and not three in order to have enough records for building an accurate model. 60% of the records are taken as training dataset so that model built is robust enough and not too flexible. The more the number of records, the more trained the model becomes. Finally, after learning about the various model techniques and their application, we confirmed on these modeling techniques: logistic regression, neural networks, and Bayesian network. Logistic regression. We chose logistic regression as we had a dependent variable as categorical variable. as a target is to predict the time of the crime, which is a categorical variable with a mix of independent variables like day of the week, police department district, and type of the crime. It is a good practice to use logistic regression. We selected the most important variables using forward stepwise selection. This diagram reflects how the variables entered one by one through the algorithm running in the behind. The other diagram shows the predictor importance for all the variables. Type of the crime was the most important variable found, followed by police department district and day of the week. This diagram reflects the regression equation for the time zone 6 a.m. to 6 p.m. Finally, we came up with the model fitting information, which was decided looking at the chi-square and the likelihood ratio. The model's fit statistics is better than the baseline model, so our model fits better than the intercept-only model. The other two model techniques will be explained by my team member Prashant.
Thank you, Malika. I'm Prashant Doshi, and I'm here to take you through the rest of the two models which we built. The two models which we built were neural network and Bayesian network. I'll take you through the model building process of these two models. The next model we're considering is the neural network. All the models built here are through IBM SPSS modeler. The reason why we chose neural network is that it can estimate nonlinear functions on any kind of dataset. Also, neural networks give importance to all the variables in the model. Here we chose time as a target variable. The type of crime, location, and the day of crime were the predictor variables chosen. From the neural network diagram, we can see that there are 5 neurons in the first hidden layer. From the classification matrix, we can see that the maximum crime of 93.5% happened between 6 a.m. and 6 p.m. This is followed by time zone 12 a.m. and 6 a.m. and then by 6 p.m. and 12 a.m. The overall accuracy we got through the model was 52.9%. The next model we're considering is the Bayesian network. The Bayesian network was chosen as it produces conditional probabilities for each level of the independent variables to predict the target variable. So it enables us to analyze each input variable and its influence on the target variable separately. Here we can see that the type of crime is the most important variable, followed by location, then by day of the week. From the conditional probabilities matrix, we can see that the probability of latency bar theft occurring between 6 p.m. and 12 a.m. is maximum, and the driving offenses committed between 6 p.m. and 6 p.m. were the lowest. Coming to strengths and weaknesses of each model, we can see that the strengths of logistic regression is that it is good because the target variable and the error terms need not be linear. The model can handle nonlinear effects, and also there is no homogeneity of variance effect. The neural network is useful as it captures complex relationships between the input and the output variable. It can also handle nonlinear effects, and all possible interactions with the input variables are captured. For the Bayesian network, the data can be nonlinear. The most important strength is that they can handle missing variables. Coming to weaknesses part, the logistic regression, we can see that if the input variables are incorrect, it may produce a wrong result. Also, the biggest disadvantage is that it cannot be used to predict any continuous outcomes. For neural network, the biggest disadvantage is that it is a black box model. That is, the results are very difficult to interpret, and we do not know exactly what type of process is going inside it. It is also prone to overfit the data. The Bayesian network also has some weakness. The main weakness is that it cannot handle continuous data. This model is prone to overfit, and also it cannot be used to find correlation between random variables. Now we can see how we are going to assess each model. As mentioned earlier, the data is split into 60% of training and 40% for validation. The models are built on training data and are now applied on validation data to check the accuracy of the models. Here we can see that the accuracy is 52.8% and 52.55% for training and validation when the models are built through logistic regression. The same way, we can see that the accuracy percentages of validation and training are very close to each other, proving that the models which we built are correct and good. So now we have to choose the best model. While comparing the best model from the three models which we built, we found that the best network model is the best. And the main reason why we chose that was it has the highest accuracy. Also, some of the factors influence our decision. Those are that because this model is very easy to understand, and the main thing is that it considers all variables while building the model. Initially, we planned to find out the most crimes that were occurring and to identify the cause of those crimes. Also, through these findings, we hope that this will create some awareness among people and thereby reduce the rate of crimes. But finally, what did we achieve? We achieved by building three models that illustrate the findings. We were pretty successful in pointing out the type of crime that occurs, which depends on the time, place, and day of the week in our case. What lessons did we learn out of this project? The most important thing which we learned was that data preparation is the most important step in CRISP DM methodology, and it takes up to 80% of the time of the whole project. Also, during the course of the project, at times the objectives and goals can be slightly changed to accommodate the findings, and the predictor variable must always be chosen according to the variable importance. And finally, getting a good and healthy dataset is very important. So we have to choose a dataset only from trusted sources. These were the lessons learned by our team while implementing the project. Here are the references which we had a look during the course of the project. Finally, we would like to thank Dr. Brian Hammer again for the immense guidance and support he provided us during the project. Thank you.